welcome to the next presentation, also from Bern, or as other people say, Zürich West. Uh, welcome, Christian, presenting Lucidi.
Thank you very much. So, good morning, everyone. Welcome also from my side. Thanks for having me. Thank you, Roger, for inviting me to speak here. Today, I'm going to present Lucidi, which is an open source project I've been working on recently. And the subtitle here is only half a joke. So today, I will want to tell you the story why it's the deployment platform that I never really wanted to build, but then had to build anyway. So just to give you a brief roadmap for today, this talk will be for about 30 minutes. I will start with a personal story about me deploying software, how I learned it, what were the different solutions that I learned. Then we will dive into Lucidi, how it works, and then we'll do a live demo. So what could possibly go wrong, right? Yeah, let's get started. Before I dive into the project, I want to give you a brief background on me. So this is me as a young child. On the right side, you can see my office. So my name is Christian and I run Zeitlos in Bern. It's a small software company. I founded it about a bit more than a year ago, and we develop software for small Swiss businesses up to universities. So if you ask me what kind of software I mostly write, it's mostly written in Go. So I do a lot of development in Go in the cloud native space. I also do web development with JavaScript and TypeScript for the front end. And that's just the short version of me. The longer version that matters for today's talk will start now. And it all starts with another photo. So this is also me. That's roughly 13 years ago. That was the very start of my professional career as a software engineer. This was during my apprenticeship at Swisscom. And Swisscom has this very special framework how they teach you how to be a software engineer. So what they do is you go through many different projects that all last about 6 months. So you rotate throughout the company and you see a lot of different departments and work with different people, and you just learn on the job what you have to learn. And one of the very first projects I was working in as a young software engineer was an internal monitoring dashboard. So imagine you have like a TV that was in the office, in the hallway, and there were like different metrics displayed on it. And the whole thing was a C# ASP.NET application running in a browser. And I was tasked to continue the development on it. And it was all good, like the development worked, and I, as usual, works on my machine, right? But then the point comes where we have to actually deploy it. And the way we used to do that is using FTP. So I don't know if any one of you remembers this FTP client. It's CyberDuck. It's written by a Swiss company. It's also open source. And I used to use that to deploy that software. And the good part was this was super easy, like super transparent. I knew like just copy the files there, don't touch anything, never touch anything, because it was all super fragile. But as long as you didn't touch anything, it worked. There was no in-between systems. It was no magic. So you owned the server. That was good. But then the bad stuff was when something broke or you had to like replicate the environment, that didn't really work. Like you had just your production environment, you had no separate dev environment, it was hard to replicate. So if something broke, it took me more time fixing the deployment than actually writing code. And I was frustrated by that. So that mismatch between the time I spent on deploying software versus the time I spent on actually building software was where this whole journey began. After my time at Swisscom, I moved on and I took a job at a startup in Zurich. And we were building a simple app in Python with Django. It was basically a CRUD app. So it had a database and we wrote some data in there. and everything was deployed on Heroku. And that felt like magic. So if any one of you, or if you're not familiar with how Heroku works, it's what we call a platform as a service. So Vercel is another example of that. So these platforms basically take care of your whole infrastructure. You just create a project, connect your Git repository, and on every Git push, your code is built and deployed within a minute or two. And that was super cool because for the first time, I could just write software, push to GitHub, and it was deployed. But then soon I realized that's good and all, but there's also quite a downside to it because you have a massive lock-in, right? These are proprietary platforms, and every workflow, like your whole deployment workflow, your build pipeline, it's all integrated into this proprietary software. And moving off of Heroku or Vercel is not just, yeah, let's host it somewhere else, but you basically have to rebuild your entire engineering pipeline. And then there was another problem because we didn't have any senior engineers or like infrastructure engineers at the company. So I didn't really know a lot about how you deploy and operate infrastructure. And Heroku is a complete black box. So you don't see what's going on underneath it. There's no way to learn if something breaks, what exactly broke. You just have to trust the black box. And as you can imagine, I was happy with it until I wasn't, because I was just pissed off. Once you had to do some more dynamic stuff, you were blocked by this platform. So your team basically never really grows up because it just has to trust this black box. After my time at that startup, it only lasted about a year. I moved on to a different company in Zurich, and it's called Monostream. And the engineering scope at Monostream is completely different. It's not just, yeah, we write some Python Django code and deploy it to Heroku, but it's more like they run the entire infrastructure, they design it, and then they code on top of it. So you have the whole stack that you have to architect for. And when I started there, they hired me mostly to be like the first front-end engineer and to do some web development. But over time, I got more into Go development and more into the whole infrastructure thing. And what we were doing there is writing something like this. So that's an internal developer platform that we built for a Swiss bank. So that project that's still going on, and it's probably over 8 years that it's running. And we were a super small team. And this was before Backstage was a thing. So there was not really a term for internal developer platform. And we started it on Cloud Foundry and then later migrated it over to Kubernetes. And when I left the company, this platform was managing around 200 Kubernetes clusters, and the team is roughly 5 people. So what I learned there is like how to really run your own infrastructure and how to run containerized apps at scale. And I realized something, like Kubernetes is amazing. It's impressive how good it is with features that you just get out of the box, like rolling updates and zero downtime deployments and a self-fixing platform in some parts. But then, as you probably all know, if you ever interacted with Kubernetes, it's also the worst platform ever because it's so complex, right? It has to accommodate all the possible niche edge cases. And I realized that when I did support. So we got support tickets from the team of the bank. And the more we onboarded, the more tickets we got that people were stuck with debugging Docker files, or they didn't know how to create a Helm chart, or they like checked in their secrets, or their secret was in the Docker image. So like all these things. And in the end, these applications were nothing groundbreaking. It's just software that had to run. So yeah, I experienced how teams lost many days just on debugging these things that were, I think, wouldn't have to be that hard. And the teams didn't really want to like hire a dedicated pipeline engineer because that's overkill. They just want to run their code. So over these different eras in my career, I think I found different pillars of what I want a software deployment platform to look like. So from the old FTP days, I would like the simplicity and the sovereignty. So you own your server, you know what's going on, and it's simple. Then from the Kubernetes era, it's how do you run containers at scale? So that scalability and that ecosystem. And lastly, from the platform as a service era, I just love that user experience, that developer experience. You connect the repository to it and it would just be deployed. So all the experience building blocks were there, but also the technical building blocks are starting to appear, like buildpacks.io and other source-to-image solutions that take your repo and turn it into a container image. Or also Let's Encrypt that automates TLS. And Helm, that's there for like easy Kubernetes deployments and packaging. And lastly, something like Cloud Native PG, which helps you to run many Postgres databases on Kubernetes with replication and production-grade reliability. So it was all there. And at that time, I thought, yeah, I mean, I just have to wait until like some big company pulls all these blocks together and builds a platform that I would really like to use myself. So I finished my bachelor's degree, I founded Zeitlos, I was working on different projects, trying to distract myself. But then something else happened, and you probably all also experienced that. About 18 months ago, a crazy orange man took over control of the greatest economy of the world. And suddenly everyone was talking about sovereignty and how it's maybe not the best idea that Vercel, Heroku, Microsoft, AWS, like all these companies are American companies. So I thought, okay, let's build this thing and let's start this project. And the pipeline I came up with was pretty straightforward. So first you push your code to a Git repository. That repository then uses a webhook notification to trigger a build job that scans your repo, figures out how it has to build it, and then pushes the resulting image into a local container registry. From there, I use a generic Helm chart that helps to build all the building blocks from config. So we don't build the dynamic templates, but just our configuration, our values generate the services and databases requested by the user. This template is then deployed via Helm to Kubernetes, where it runs as a containerized application. So that's the rough workflow, how a deployment works in Lucity. And for the UI, I knew I don't want to reinvent it because I already was using Railway, another platform as a service, and I just straight up copied their UI because it was so good. Me as a solo developer, I couldn't invent something better. So sorry, not sorry, Railway, I just copied that. And here's where Lucity gets a bit different. Like this is the system architecture. And as you may be able to spot, there's no central database. So there's no database where all your deployments are stored and your different projects and your environments, but rather all the state of the platform is derived from the surrounding systems. So for example, in Lucity, we have workspaces, which are essentially a tenant. And the workspace is nothing else than a group in your identity provider. So we use Lock2, but you can use any OpenID Connect compatible provider. Then the next abstraction layer after the workspace is a project. And the project is just a group of Kubernetes namespaces that all share the same Lucity label. And within a project, you can have many environments, for example, dev, staging, prod, and test. And an environment is just a Kubernetes namespace with the correct label, and so on. I think you get the point. So all the resources are derived at runtime from the state that is given by the surrounding systems. And then as you can see on the right side, there's also the build namespace. So the first on the left is the Lucity system namespace where all the core components live. And on the right, there's the builds namespace. And that was one of the core challenges. How do you run someone else's code on your own infrastructure without it being a security nightmare? That's why it's in an isolated namespace, and the builds are done using BuildKit. And then on the very right, you can see an example of how an environment, like a workload environment, would look like. So that's also an isolated namespace where the customer workloads are deployed just as deployments and PG native custom resource definitions. So the good thing about this is if your control plane dies, this central piece, it's only that goes down. So your workloads are not affected by that. So then like the next step was, and it's the punchline of the whole platform, that sovereignty does not equal, like open source does not equal sovereignty. I think there are many open source projects where you can read the code and fork it, sure, but if you build processes around an opinionated system, it's not that easy to get out, even if you can change the code or look at the code. So I knew I wanted this project to be open and transparent. So I came up with the concept of ejectability. I think looking at the crowd, most of you probably remember doing this. If a disk was stuck in your computer. And I took that idea and I realized if we build Lucity on top of standard tooling, you can also just eject out of the platform. So as a user, you can just click a button on the dashboard and download your Helm chart, your build pipeline, all your environment configuration, your different databases configuration, and a little documentation how to install it, and then you can move it to another cluster where you don't have to run the system and you can just run a Helm install and it will run as well. It's very standard tooling as you would do it if you set it all up by hand. So that was now a lot of talking, but now I really want to show you how it works. And fingers crossed this works, because we had some issues with connectivity, but I think they're resolved now. So let me give you a demo. Good. So now I just have to find my pointer. Very good. Let me zoom in a bit. So this is the test app that we're going to use for this demo. It's just a Next.js application that has, as you can see, it doesn't have like any Docker file. What it does need though is a connection to a Postgres database. So it's a simple application that's for voting on feature ideas. So this is the Lucity dashboard. Let me sign out. So you can see you log in with GitHub. Currently it's only GitHub, but more providers are in the works. And then you land on your workspace overview. So up here you can see I currently am a member of 2 workspaces. And as I said before, these are like tenants. So these could be like different teams or different companies. Now let us create a new project, and then it asks me if I want to create it from a GitHub repository or a container image. I will choose a GitHub repository. And here I can select all the different organizations that I have. So let me go to Zeitlos and I will search for this test repo. Select that, let's give it a nice name. And create the project. Now what happens in the background is let me get my Kubernetes dashboard here so I can show you. So as you might be able to see, sorry, it might be a bit small. What it did is it created a new Kubernetes namespace and labeled it accordingly with these Lucity labels. It then created the service we asked it to create. So this is just a regular Kubernetes deployment that it created. And in there, our service is running. So this went super quick now. We kind of missed the build step. But what happens is it triggers a build using Railpack. So that's the source to image technology that I use. And it pushes it to the local internal container registry. So if you have a look here, this is SOD. This is a OCI compatible container registry. And we can see here on the recently updated images that it built and pushed this image. So we can see the build cache here, and the digest is already older because it was still in the cache, so it's just referencing another blob. And then here on the service, now this is not useful because we have to expose it to the internet to be able to use this web application, right? So we have this feature with platforms domain that we can just generate a domain ending in lucity.app. So we can see that here. So it's the name of the service and environment and then some randomly generated suffix. So if we click on that, we can see here is our Vouch test application. And as you can see very clearly, the database is not connected, so it's not usable right now. So let's go back to the dashboard and let's create a Postgres database. So we will just call it main, create the database. And now we can go into the service and we have to configure this database connection string as an environment variable. So we go into the variables tab. And here we can add a variable, and we can not just add static environment variables, but we can also click this little magic button here, and then these connected variables appear. So we can insert the database URL and reference the database URL of the main database we just created dynamically. So that means this includes the host name and the username and password it needs to connect to the database. And we can just hit save. And this will now take a second, but what it does in the background, as you can see here, it will create a new deployment that references that connection string as a secret reference within Kubernetes. So if we go onto this and look at the container that is running, you can see that the database URL variable referenced the secret of the database. And now if we go back to our test application, we should be able, there you go, to refresh it. And now we can submit the feedback and request a new feature, for example, S3 object storage. Like this, submit it, and then the idea of this dumb little application is that you can just upvote features here. And if we go back to Lucity, I can also show you the database integration. So now if we go on the database and click on tables, we can see this is a new table that was created by the app. And here we can see the title of the feature I just created, the description, and the 3 upvotes that I gave it just now. So you have a small database explorer built in, and you can also query directly using SQL and have an overview of your database. And then for the last feature that I teased before, the eject feature. So up here you can click on eject and you get presented with this window, and here it says, don't worry, if you download this, it will still keep running, but we can download a zip file. And if we unzip that, let me get this over from the second screen. So we get a folder, and in here is all the configuration that was automatically generated by Lucidi. So it's like a normal Helm chart with templates. The environment configuration is in there. And also this Argo folder. Currently it's still using Argo CD like GitOps for deployment, but don't worry about it. I'm currently moving that out because it turns out you don't want to automate processes using GitOps directly if it's like deeply integrated like this. So in the future, it will just use pure Helm deployments and not do the round trip with GitOps. Perfect. And last but not least, the most important feature, it also has a dark mode. So that worked out surprisingly well. Before wrapping up, I want to quickly mention the roadmap. So as I teased before, one of the main features I definitely want to add soon is support for object storage, so S3 compatible buckets. Then integrate vulnerability scanning for the workload, so you know the CVs that are running within your workspace. Also, Redis compatible key value storage, encrypted secret support, so that's definitely one for OpenBAO. And also arbitrary Docker file support, so you can deploy any application, and more Git providers, so GitLab, Bitbucket, some generic Git servers. So that's the roadmap for the near future. So that's Lucidi. Thank you very much. You can find it on github.com/zeitlos/Lucidi. Check it out, give it a star. You can also test the hosted cloud version on lucidi.cloud. It's very early stage software, so it works, even it's billing integrated, everything, but you will definitely find some bugs. So if you find any bugs, just open an issue on GitHub or shoot me an email. I will love to answer these and make it more stable and better over time. Thank you very much for listening, and now it's time for Q&A.
Thanks, Christian. One question: in your front end, which was based on Next.js, you didn't provide a Docker file. So how did Lucidi guess how to create the image?
So what I use for that is a project called Railpack. It's created by Railway, and it's called source to image. So it uses certain rules to analyze your code base. And for example, it looks for a package.json file, so it knows, oh, it's probably Node. And then it looks in the dependencies and in your scripts to figure out, oh, it's probably a Next.js file. And then it knows, okay, it has to run npm run build, your build script, and copy in all the dependencies. And so it has these standard rules for building like many frameworks. So Next.js is one of them. Others are like Vue and React, like all the front-end stuff, but also Go applications, Python stuff. Yeah, pretty much all the major frameworks people use.
Thank you.
And the good thing about that is also that people don't mess up their Docker file. So they don't copy in like some secrets or the whole source code. So it's basically best practice out of the box and cacheable.
I have a question. The mic guy, but I hope it's okay. Thanks for the presentation about the ejectability feature. I think it's really cool. I was just wondering, like, you know, the real life projects get complicated very quickly, and so it works nicely with the demo app. But you know, with as the projects get complicated and with more and more components, will it support all that, or where do you see the challenges for like bigger deployments and projects?
So that's a good question. I would say Lucity aims at the projects that are currently using a platform as a service solution already, or are like simpler projects. I don't expect like a super complex enterprise platform to be deployed using Lucity, because it's like that's probably too much. But for many like agencies that are building websites or basic platforms that have just like a couple of services, that should be fine. Like this complexity is fine. I think you hit some limits when you want to do some advanced routing stuff, like path-based stuff. I don't plan to support like these edge cases in the near future. I think it's like if you need that, that's like fine, but then just go Kubernetes native. But it's more like for these small to medium-sized projects that I aim to make this work.
Great talk, thank you. Are there any plans for an inject feature if I later change my mind, or if I want to download the archive and mess around with the files and bring them back to the platform?
Yeah, I mean, I already thought about that, because what I can see that this could be useful if you have a Lucity deployment on-prem or like air-gapped, and you have a Lucity like the cloud deployment, and you just want, for example, you start out on the cloud. It's the same with many software as a service, right? They have like this simple managed service, so you can test it out. And maybe you start on the managed version, and then you want to move off to your own deployment. So I think an import feature would be great. The question is how, because if I can just like import any deployment definitions, that might be a bit tricky to support and like to keep it secure. But yeah, I think at some point an import will happen.
Cool, thank you.
Thanks.
Hello, thank you. You mentioned that you can run Lucity on your own infrastructure, but also there's the managed infrastructure that you showed. Where do you host that?
So it's currently running on Hetzner, and I've prepared for that. So it's running on Hetzner, and as you all probably know, or the ones that are familiar with Hetzner, you can like create cheap VMs there, and it's the VMs for Lucity run in Germany, but they don't have a managed Kubernetes offering. So what Lucity runs on is another project of Zeitlos and Natron, which is another company from Bern. And together we created FlexPlane. So FlexPlane is basically a virtualization platform for containers and VMs that runs on top of Proxmox. And it has its own managed Kubernetes solution. So that's what it currently runs on, and it's really great for what it has to do. And thanks to this simple setup, we have a cloud hosted in Europe. It's very affordable, and also because I'm in control of the whole virtualization, I can just like build it the way I need it.
I have another question regarding scaling and so on. Is it possible also to buy UI to just say, hey, I want to scale up some new pods and stuff, or how does that work?
Yeah, so it has an auto scale feature that you can enable, and if you like that, I don't know, it's not always the best idea, but you can also just create new instances via UI, and you can size them, so you can do vertical scaling and horizontal scaling.
Cool. No more question? Then thank you very, very much, Christian.